Okay, so hey everyone, I am Aditya Sharma. Today I will be talking about demystifying communication between JavaScript and native code in WebViews. And our agenda for today would be to discuss WebViews and hybrid apps, the usage of WebViews, and the challenges which you face in WebViews, followed by establishing communication between JavaScript and native code, the internals of Java-JavaScript bridge, followed by a short Q&A. So let's start. So WebViews and hybrid apps. Basically, WebViews allow you to display web content as a part of your app's UI. Now, you can consider WebViews as an embeddable web browser, but an important thing to note is that it lacks the functionalities of a fully developed standalone web browser. So what does exactly WebView mean in Android and iOS terminology? So in Android, the WebView class is an extension of the view class, which is a basic building block of your app's UI. Similarly, in iOS, the WK WebView class is an extension of the UI view class. UI view class, you can consider it as an equivalent of the view class, and it is also a basic building block of your app's UI. The diagram which you see on the right represents the CRED app as a hybrid app. So around 20 to 25% of the screens in the CRED app are built as web views, while the rest of the screens are in native, which includes Android, iOS, and Flutter. So as I explained, web views are built using web technologies. So you can use anything like Vanilla JS, React, Vue, any framework of your choice. And yeah, there is one more way to identify if a screen is a web view in a mobile app. So consider CRED. You all can take out your Android device, and in the developer options, you can turn on that setting of show layout bounds. And when you go to say the profile screen of the CRED app, which is actually a web view, you will see a cross on that screen. Another example is the Swiggy app. So Swiggy app has their Instamart and Genie products, which are built as web views. If you enable that setting in your device and go to Instamart or Genie, you will see a big cross on that screen, which indicates that that screen is built as a web view. So it is just a way to identify if a screen is built in a web view. Coming to usage of web views are helpful when your app's content changes frequently, and they allow you to iterate faster, run experiments without doing an app release. So what does this actually mean? So suppose consider an example that you are launching a new product flow and you know that it would require some frequent changes or product iterations in the flow. So it is better to build that flow in WebViews, because doing those changes in the coming weeks would not require an app release. An app release would require you to submit the Android and iOS builds to the respective Play Store and App Store. Whereas in WebViews, you can just run your pipeline, merge your changes to master or main, and the changes will be deployed to production. So if you, third point is, if you already have a responsive web app, having the same app work as a hybrid app on a variety of devices is fairly simple. So this is about the usage of web views. Now, coming to the challenges which you can face while building web views. So just to reiterate, these are just the challenges and not exactly trade-offs of web views. You can solve each and every challenge in some way. Let's go over them. So the first challenge is that web views need extensive testing on all platforms to support different versions of web views and their implementation. So the thing is, you have built a screen in WebView using, say, a framework, React. The same code will run on both Android and iOS. And the implementation of WebView is different in Android and slightly different in iOS. So it needs extensive testing. In CRED, we have a manual QA team to do that. Second point, WebViews have slow load times on low-end devices and devices with poor internet connection. As the screen is built in web, the code you are getting is actually not installed on your device. You are getting it on the fly. So this can also be solved by introducing a caching layer or something, a resource manager sorts of thing, which caches the common resources, like say the fonts which you are using on the app side and the fonts which you have on the website and the common assets which you use on app and on web. Third is handling of camera, things like native functionalities, basically. Handling of camera, contacts, permissions, image compression, etc. is better in native. Next point is about the nice ecosystem of Google Play. So I'll explain this point with the help of polyfills. In web apps, to support your web app on older browser versions, you introduce polyfills. Now, there can be various ways in which you implement a polyfill. Say you use Babel or you write the code yourself. Say for example, promise.all or promise.all settled. You write the code yourself. Now, this is adding code to your bundle, which ultimately increases bundle size and load time. What happens on Android? You have a nice ecosystem of Google Play and you upload your AAB to the Play Store. And AAB is basically Android app bundle. What this means is that you upload a compilation of the source code and the resources, and you leave the generation of APKs to Google Play. What this means is based on the user's device configuration, they will get the respective APK which is supported in their device. So Google Play, there's a nice ecosystem of Google Play and Android. Then the last point is about security issues. I'll elaborate a bit more on that in the following slides. There are some security issues in WebViews which you need to take care of. Now, these two screenshots are from the CRED app. It is a simple document upload functionality. It's a very common functionality which you might have seen in various apps. You can choose from gallery or take a photo and upload your documents. Now, as I explained in the challenges, these functionalities like handling camera and image compression before uploading them is better in native. So this part is built in native. Consider a flow which you have built in web as WebViews, and from that you need to ask the user to upload documents. So basically from web, from your JavaScript code, you need to open this bottom sheet. So somehow you need to establish communication between your JavaScript code and Android code to trigger this bottom sheet, right? So now taking this example, I'll move to how you can actually do that and how you can establish communication between JS and Android code. So on Android side, what you can do is you can create a class, and inside that class, you'll create a function called start file upload, which basically opens that document upload bottom sheet, which has options to choose from gallery or take a picture. And what you do next is you annotate that function with @JavaScript interface, and you use the @JavaScript interface API of the WebView to expose that method to the website. Now, what this API is exactly doing, you are passing an instance of the class and a string, right? So we are passing mobile client. This string is exposed to the global context on web, which is window. And from website, as you can see in the last, you can do window.mobileclient.start file upload. So from web, you can call that start file upload method using window.mobileclient.start file upload, and it will trigger that bottom sheet on native. So one point here to note is that only methods annotated as @JavaScript interface are exposed to JavaScript, and Java object fields are never exposed. Coming to the security issues, which I mentioned in the challenges, till Android Jelly Bean, we did not have this system of @JavaScript interface. So every code which was written on the Java side was exposed to the website. Now, most of the apps in today's world are not supporting Jelly Bean, so that is not an issue. So till now we saw that you can write a function on Android side, and you can expose that and call that from website, right? The reverse is also possible. You can expose functions from website and invoke them from your Android code as well. So just consider you expose this function called on payment finished on web client. You can choose, web client is just a name which I took, but you can take any name like window.web interface or window.web and expose this function. So let's try to understand the use case, why this needs to be done. Consider a flow which is built in WebViews, and in that flow, user checks out and makes a payment. The part where the user makes a payment is built on native. Now, after the user makes a payment, he or she lands on the post payment screen, which is again built on web as WebViews. The post payment screen will show the status of the transaction, successful, processing, or failed. So again, you need to establish communication between native and web to open the post payment screen after the payment has been done. So you expose a method on the website called on payment finished, which will be called from the native side, from Android, after the user has made the payment. And based on that, we'll navigate in web, we'll navigate the user to the post payment screen using something like history.push to the to that route of post payment screen. So from Android side, you can use the load URL API of WebView, and you can just use the syntax called JavaScript colon and call your method on website by web client dot on payment finished and pass the status. Coming to the JavaScript bridge, the communication which we just established between JS and native code in Android is powered by this bridge, whose purpose is to establish interaction between two VMs, Java and JS. And Java and JS VMs are independent and unaware of each other's existence. They can work in different processes too. And the third point is about references. The references from JS objects to Java objects are virtual. They don't exist directly, and the bridge holds the Java objects for as long as it is needed. These points will be more clear in the following slide, where I use a diagram to explain the internals of the Java-JavaScript bridge. So the Java-JavaScript bridge has two sides, as the name indicates, the Java side and the JavaScript side. On the Java side, it is tightly coupled to an instance of a WebView class. And on the JavaScript side, it is coupled to an HTML rendering engine. And now coming to the WebView class, which is an extension of the View class in Android. The WebView class owns a set which holds all injected objects to prevent their collection. The WebView communicates and manages an object called web contents on the C++ side. And this web contents delegates all Java Bridge related requests to Java Bridge host. So I have simplified the relationship between WebView and web contents object for the sake of understanding. Now, the web contents object on C++ side communicates to the rendering machinery, to the right side of the bridge, using Chromium's IPC mechanism, interprocess communication. That's a whole new topic. I'll not go into the depth of IPC. But next, what happens on the rendering side, on the rendering machinery, is that render frame corresponds to a single HTML frame, and it owns a global context object, which is the window object in web. And corresponding to each object injected, like we injected mobile client, right? We were calling window.mobileclient.start file upload. There is a Java Bridge object instance which is maintained. What is the use case? The JS side, this is like a wrapper. Consider this like a wrapper. The JS side communicates to Java Bridge object when the corresponding objects on JS side are garbage collected. So yeah, that's about the Java JavaScript bridge. I'll go this once again in short and reiterate. So there are two sides, Java side and JavaScript side. Java side is coupled to an instance of the WebView class. JavaScript side is coupled to an HTML rendering engine. There is a WebView class which owns a set where all injected objects are stored to prevent their collection. It manages a web contents object on the C++ side, which communicates to the rendering machinery using Chromium's IPC mechanism. Render frame here corresponds to a single HTML frame, and it owns a global context, which is window in web. And corresponding to that, a Java Bridge object instance is maintained, which is sent a notification when the JS objects, corresponding JS objects are garbage collected. Coming to the second security issue, which I mentioned in the challenges slide. When you expose methods from Android side, they are exposed to all frames on web. Now, what does that mean? It gets exposed to the render frame, the main HTML frame which you have, and it gets exposed to all the iframes as well, which you have. So to overcome this challenge, you need to make sure that in your app, you are only importing, trusted content in the form of iframes. If you load content from a third party in iframes, your native code, which you exposed via @JavaScript interface might be exposed there. So you need to be aware of this security issue. Although you won't get a security sign off if you try to deploy that code. So continuing with the bridge, the methods of Java objects are invoked on a private background thread of WebView. They are not invoked on the main browser thread. And second important point is the calls to this interface method are synchronous. Like I call start file upload method from website, or I call another method which returns something. So the calls are synchronous. On the JS side, it will wait, stop and wait for the result to be returned from the invoked method. Yeah, that was all about the Java-JavaScript bridge. Coming to how this works in iOS is, before starting this, I would like to summarize the Android part. So Android part was comparatively simple. There you created a class, you wrote a function, you annotated it with @JavaScript interface, and it was exposed to the website, right? The same process is a bit different in iOS because the implementation of WebView is different in iOS. In iOS, we have a WK WebView, and in Android, the WebView is an extension of View class. In iOS, it is extension of UI View class, and the implementations are different. So what is happening here? Let's see how you can establish communication between JS and native code in iOS. Let's see, try to understand it step by step. So first you create a user controller, then you create a JS script, which again, I'm taking that same example, start file upload. You need to expose that method to web. So you add this to the user controller using the add user script API. After that, you create a message handler and you add it to your user controller. And now what will happen is when you call the method start file upload from web, it will run this line window.webkit.messagehandlers.start file upload.post message. And what will that do? It will invoke the message handler. Inside the message handler, you will write the implementation to open that bottom sheet or native site to choose from gallery or take a picture. So it is a bit complicated in iOS. And after these three steps, these are some basic stuff like you'll create a WebView configuration object. You'll assign the user controller you created to the WebView configuration. You'll create the WebView and load your web resource in the WebView. So here you load a URL in the WebView. Consider the URL can be simple, like you load www.google.com in a WebView. So it will open Google in a WebView. And yeah, that is the process to expose start file upload to the website in iOS. And you might be wondering, like on iOS side, why did I write this JS code window.webkit.messagehandlers? So that is because, and first point is like the window.webkit namespace is exposed only in the WK WebView in iOS. So if you go to a normal site, say google.com, you go to the console and you type window.webkit, that will come undefined. But that namespace is only created in iOS WebView. The reason is if you don't write this JS here, you will need to serve separate JavaScript code for Android and iOS, and that is not ideal. So you write this line here. When you call this function, this line runs and this notifies your message handler. Inside the message handler, there are some more details. I'm not going into the depth, like WK, it implements the WK script message handler protocol. There is a term called protocol used in iOS development. And what it will do is inside the message handler class, this class, right? You should have defined this method. You should have implemented this user content controller method. Now iOS will automatically call that method and implement your code, which is opening that native bottom sheet of choose a picture or take a picture or choose from gallery. So yeah, I'll summarize this in short again. You create a user controller, you add your script to the user controller, then you create a message handler, you add your message handler to the user controller, and then you create a WebView and load your web resource in the WebView. So this is how it is working in iOS. And as similar to Android, You can expose functions from website and invoke them from your iOS code as well. Like the reverse is also possible in iOS. Same example, the payment example. You can expose on payment finished on web client in window. And from iOS side, you can use the evaluate JavaScript API to call this on payment finished method. So this API also has a second parameter which you can see, which is a completion handler. So what this will do is, once your function runs, your on payment finished function runs, it will call this completion handler irrespective of if the function you have defined on website is successful or failed. Like even if the on payment finished method fails, it will still call the completion handler. So yeah, that is the iOS API and how you can call it in iOS. Uh, Moving to the next part. Yeah, one more thing here. Uh, I have just written pseudocode here, and the way of writing these things in iOS can be, and in Android can be different depending on the architecture you use. So in CRED, we use Viper architecture. So I did not include details of Viper architecture here. I just abstracted that parts out to simplify the explanation of how you are actually communicating between JS and native code in both Android and iOS. Yeah, that was mostly it. I have added some resources. If you are interested in diving deep on the WebViews concept, I'll share the slides with you. And yeah, the thing is, like, I have covered only one aspect of the topic, which was establishing communication, but the WebViews concept is quite, uh, detailed, and the content is scattered. So you will not be able to find the content in a single place. You'll have to read from multiple sources, and you'll have to read separately for Android and iOS to understand it in depth. So yeah, I have added a few resources. Maybe you can scan this QR as well if you want to access the slides, uh, or I'll share the slides with you after the talk on DM. So yeah, that was mostly it. Uh, any questions? Acha, types. Okay. So yeah, as I said, there is a lot of more depth to it, and you are right. Like the return types and conversions are handled by the Sun Connect 32 spec. And what it means is key the types of variables like primitives and all is different on the Java side, and it is different on JavaScript side. Yeah. Yeah. So they have defined a spec to, and they say ki these are they have given a list of types ki these are the only types which can move back and forth between the bridge, and these are the only types which are compatible and which can be returned from Java to JS, and how they are exactly converted. So you have to, if I take an example from CRED, say we are hitting mix panel for instrumentation, right? And we are tracking events there. So when we call that method, it invokes a method on the native side, which hits mix panel API. And the event and the attributes for tracking, which you pass to that method, have to be stringified. Like you'll use JSON.stringify before passing them. That is just one simple example. But yeah, there is a spec for it which defines the list of values, list of types which can be returned. Yeah, so that's what the spec says. Ki, that methods can fail if you do not pass the required type. State management is working on web, no? Like the whole screen, say, consider the profile screen of Cred. It is built as a web view, which means you have built in some web framework, say Vanilla.js, or you have used a framework, say React. So you are handling all the state management on your side. You can use any library like say Redux, the stand, etc. But all that state management will reside on the website only, just like desktop web projects. No, no, no. So, acha, you are matlab, asking about API calls, right? Like, huh, data in common. About API calls, huh, so that is also decoupled. Like we call the API separately on the WebView side, and that is decoupled from the native side. They call APIs via a different Kong layer. We call APIs via a different Kong layer. Yeah, matlab we don't pass in the network request because that is not safe. Like we don't pass things like user ID in the network request. They are taken from the Kong layer itself. Kong API gateway via a plugin. So it transforms and adds the X user ID, say header in the request, and you can the backend service can extract the value from the that header. Acha. But that is also decoupled, like the keys which you talked about, right? That is also decoupled on native and yeah, yeah. Right. Sure. Yeah. Sorry. Any limitations? Yeah, so just like I explained the document upload flow, right? So why is that? Why are those two screens built in native? It's because the native functionalities like camera and the image compression, say you want to compress the images before uploading them, those things are better in native. You can do them on web as well, but there can be performance concerns or there can be some other issues which you might face. Hmm. Okay. One example I can think of is animations, like really complex animations you can do on desktop web easily. And that might not be possible in WebViews because you don't have much control over the GPU. So if you build those animations in native, you can sometimes overclock the GPU as well for the performance of the animations. That is one example I can think of. But other than that, yeah, you can, well, there are a lot of flows, as I gave examples of Cred and Swiggy, right? Like Swiggy has also built whole Instamart and Genie products in WebViews. So matlab, it does have challenges, as I explained, but it gives you advantages as well. Like this, the same code is used in both Android and iOS. So development is fast. Performance would depend on the type of the screen. Matlab, just as I took this example of animations, right? Like if it's a very animation heavy thing, we might not do it on web views. We might do it on native, but it depends on the requirements. Like while using the app, if you are asking from a user point of view, you will not feel a difference. And if I have not told you this show layout bounds thing, right? You will not be able to distinguish between a native screen and a web view screen as a user. A normal user would not be able to distinguish since all of you are developers. You might be able to distinguish, but yeah, from user point of view, they will not feel any difference. Yeah. Yeah. So we do face some issues with web views in iOS, and that's because like some things can't be controlled. They are dependent on the implementation of the web view. And like you gave an example, that is one thing which we also face. Like when you there is actually no way to tackle that. Like the text will go up. So he is basically giving an example of an input field where a user types. So when you click on it in the iOS app, it will open a keyboard, but the content will not go up, right? So that is one issue we still face. We have introduced some hacks which are not elegant, but yeah, that is one issue which we also face, specifically on the iOS side. Any other questions? Okay, thank you. You can reach out to me on Twitter.